Hi, and welcome to RouterFreak.com's CCENT, Cisco Certified Entry Network Technician. I'm Joe Wilson, and I'm going to be your lovely host here for video 3 of our CCENT video presentation. Today we're going to go over a pretty abstract concept that a lot of people have a hard time with, and that is the OSI model. Now, the OSI model, well, OSI stands for Open Systems Interconnect. It's an acronym, just like everything else you would think of. But the OSI model here, this is a reference model that we'll get into this in a little bit. But basically, it's a framework, so to speak, for vendors and manufacturers when they're building network equipment, that they know that they'll be able to build their equipment in a way that all the pieces will basically fit together. So, what is a model? Well, you got a model of clay, you got a supermodel, you got like our 7-layer burrito that we have down here. And really, it's kind of funny because the layers of the OSI model aren't too different than this 7-layer burrito, because there's 7 layers of the OSI model, and each layer basically describes and depicts a part of the physical network and how it all lays on top of each other and how it interrelates with each other. So really quick, let's go into this and start breaking this down. So the layers of the OSI model. Well, again, the OSI model, it's broken out into 7 layers, and it's done this way so we can break up these network functions here, into pieces and parts that are digestible in a way, but that each network equipment manufacturer can focus on. Okay, it also allows us to create some standards for the equipment manufacturers. So when you have a manufacturer who makes a network card, when you buy it, because they've built it based on some of these standards from the OSI model, that it will work on your network. It also allows vendors to specialize in areas of the network. So you have equipment vendors that are focused on routing. Some are focused on switching. Some are actually focused on the chips inside the routers and switches. And all this kind of works together, and it's working together to ensure that we've got interoperability, that all of these cards work together, all these devices and people and equipment and manufacturers all are able to work together. So here it is. Here's the OSI model, straight up and down here, from top to bottom. And really, I hate to tell it to you guys, but you're gonna have to memorize this. You really are. You're gonna have to take this to memory. Let me just spell it out there. Memorize it. Memorize it. If I can spell. See, this is why you can't get me on a whiteboard, because I'm terrible. But anyway, so we have the 7 layers, and if we start at the bottom, this is the physical layer. And just as you would imagine, as we go up in the layer, it goes all the way up and gets more and more complex until we get to the application itself. So when I say that you're going to need to memorize this, well, unfortunately it's true. But what we do is there's several different mnemonics, acronyms that we can use in order to help us remember all of these layers: the physical, data link, network, transport, session, presentation, and application. Now, one that I've used in the past is, starting at the top to the bottom, is all people should try networking like meaning the L in data link, like Phyllis. Well, yeah, who's Phyllis? I don't know. Just I made it up. Another one, if you that I've heard other people use is please do not throw sausage pizza away. Okay, so whichever one you want. All people seem to need data. All people seem to need data processing is a third one. But however you want to memorize it, make up your own. But you need to memorize it. And kind of highlight this over here. Memorize. So anyway, so what are we going to do? We've got each of the layers. We've got the physical layer, the data link layer, network, transport, session, presentation. We're going to go through each one of these and how it relates to how this OSI model works in real life. How we use it and how it how you use it every day. If you've used a computer and if you've gone on the internet or out on the network to get any kind of application or whatever, the OSI model has been there. You just didn't know it. So let's get on and let's break all this down. So we've got, from the top down, we've got the application. Now really I think I'd rather go through this from the bottom up, but I wrote this slide from the top down, but we can take it that way. So the application is, if we're looking at, if you're sitting at your computer and you've got a web browser open and you want to go out to the internet, the application that we're looking at right here would be the browser. The browser would be the application in this OSI reference model here. So then if we break it down as we go out and we want to browse out over the internet, the next model would be, in the presentation, would be, well, that would be the HTML. When browsers render a web page, well, they're rendering a web page using a markup language, and that is hypertext markup language, HTML. And this is data that's formatted to be sent over the network as we come down. So basically, the browser is going to provide the browser application is going to provide network access for this application. The HTML now is going to is doing the job of presenting it to the application. As we break it down even further, the session would be your HTTP protocol or your hypertext transport protocol. This is what's going to manage your session. It's going to start and end the session. It manages the session and manages your HTTP connection to the web server. And then as we dive down through the network stack some more, we get into the transport layer, which is the TCP and UDP packets that are going to carry this HTTP, the HTTP session messages over the network. This is where the networking, most network engineers start. Our job is going to start right about here. From here down is where network engineers really start digging into what the meat of the network, the TCP packets, UDP packets, how this is sent. Essentially, you have two ways that you can send your traffic over the network. You can be sent reliably or unreliably. And the difference is, well, basically reliably, a reliable message is when I send you a message, say for example, we're in World War II and the bombs are going off and the shrapnel's everywhere and there's loud explosions everywhere, and I got a radio and I'm dug in a foxhole and I'm trying to communicate to the headquarters that I need an airdrop. I need air support. Well, in order to make sure that they know, hey, don't drop a bomb on me, drop it on my enemy, first thing I'm going to do is I'm going to say something like, headquarters, this is front line, come in, over. And what's the next thing I'm waiting for? Well, the headquarters is going to say, this is headquarters, go ahead, I read you, over. So what did he just do? He acknowledged my first communication, saying, okay, I can hear you. I hear you, send me something. So my next thing is my next transmission is going to be, Roger, headquarters, this is Private Joe, and I'm under fire. How do you copy over? Roger, I copy you. You're under fire. And every time it goes back and forth, I send a transmission. He acknowledges my transmission. This is what we're calling a reliable communication, where I send a packet out, and the distant end or the receiving equipment will acknowledge my packet, acknowledge that they got my packet. Whereas to contrast this with unreliable communication would be more like, I'm trying to think of a good example. I guess, well, the Postal Service in a lot of ways. I go and I write a letter to my mom. And I write that letter and I put it in an envelope and I put it in the mail and it's gone. I don't ever know whether she got my mail or not. I assume she did. But I fully don't know whether the post office ever delivered it. Now maybe later on my mom will say, oh, hey, I got your lovely letter. It was really great. I'm glad to hear from you. Then I know, oh, great, thank you. You did get it. But that's what I mean by unreliable. UDP is an example of an unreliable protocol, where it's a datagram protocol, unicast datagram protocol. And what it does is it just sends the transmission out, sends the message out, and it doesn't care whether it gets there or not. It just, you get there, you're on your own, I hope you get there. TCP, on the other hand, is, I'm very concerned about whether this message gets to the other side. So before I even start, I'm gonna open up and I'm gonna do what they call a SYN. Well, we do it's essentially a synchronize, but we're gonna do a SYN packet, and then we're gonna wait to get an ACK or acknowledgement back from the other side. So we SYN, ACK, and then SYN ACK. We do a SYN and then a SYN ACK where they're acknowledging the SYN, and then I acknowledge, okay, yeah, I got your acknowledgement back. So SYN, SYN ACK, ACK. And this is what's known as the TCP three-way handshake. TCP three-way handshake. So the TCP three-way handshake is just this reliable method that we can send packets across the network. So we do a SYN, the distant SYN does a SYN ACK, then we acknowledge a final ACK, and then we send our data along the way. Data, boom, okay. And then we start sending. So, next. Oh, that looks terrible. Okay, so our next layer in the OSI model is the network. And this is the logical addressing. This is where IP addresses live. This is where routing takes place, and this is where our packets learn the best route or the best path to their destination is through the network. Data link layer. This is the physical address. This is where network cards, all network cards have what's known as a MAC address, or media access control address. MAC address. This is the hardware address. This is the physical, it's a burned in hexadecimal number burned onto the card itself. And this is this becomes a physical address on the network. One of the other responsibilities of the data link layers is ensure that your data is sent over the physical media error-free. Switches operate right here at the data link layer. This is where the switches operate. And then finally, we've got the physical layer, which is the cable. This is where all the electrical signals get onto the network. This is where the ones and zeros are. All that happens here at the physical. So if we look at this, we have the physical, which is the wire, the physical cable, where all the electrical signals get onto the network. These are just the binary ones and zeros that are being transmitted. Then we go up and we got the data link layer, which has information like the physical address, the MAC address for our computer on the network. The data link layer also makes sure that your data is error-free, and this is where switches operate. Then we move up to the network layer. This is where routers are, and this is where IP addresses are. This is the logical addressing. Down here at the data link layer, this was where this was the physical address was, the physical hardware address. This is where the logical address is. Your IP address is a logical address somewhere on the network. Then we go up to the transport layer. This is where TCP UDP is. This is where your packets are either being sent reliably or unreliably. This is also where port numbers are. Then our session, and with session, when we're using the example of surfing out on the web, HTTP was an example of our session. And then presentation, which would be like the HTML on a web page. And then finally the application, which is the browser that presents all that and interacts with the user. So here we are. Here we're going to do an example of a real world transaction through the OSI model. So here we have our, like we said before, here's our little computer, okay, and we've got our browser, and he opens up, or she opens up our browser, little Firefox or whatever. We'll call it IE. So there's our browser, and we open up our browser, and that browser is the application. Through that application, we see the HTML that's presented to us on the web page, and then finally the HTTP, which would be like http://www.cisco.com. To get there, we're going to use TCP, and on this in this TCP for web, we're talking TCP port 80. So that may not. What's this port business? Well, we'll get to that in a second. Let me finish this real quick, and I will show you. So the network. So for me, my network, is going to be my logical address, which is my 192.168.1.10, I think. My data link layer, that's my MAC address. This is going to be like a 01A/E57005F0. It's a 16-bit MAC address. This is our MAC. I'll just put this over here, MAC. That's our physical hardware address. And then finally, we've got the cable right here, where we get on it. Now, one thing I wanted to show you as our request went down through the packet, we got on the wire, we come across over to where we're trying to get to. We're wanting to go to Cisco.com. So here's Cisco.com, Cisco. And as it gets to Cisco, it gets onto Cisco's physical network. It comes across the physical cable. It finds this server. It's going to find its MAC address on the wire. That's going to translate to an IP address. That's going to translate to TCP port 80. That's going to have the HTTP that we're looking for and the HTML. And then finally, on this side is the web server, the www web server that we're looking for. Okay, so in order to kind of explain this, I want to let me do something. I'm going to open up a DOS prompt here. Okay, and what we're going to do is there's a command you can run called netstat. And what netstat does is it shows you the ports and IP addresses that are in use on your machine. So here we're looking at, I've got two connections open to these foreign addresses. You've got a local address, which is my address on my machine. The protocol, which is TCP, which we're saying that's reliable, a reliable communication. We have the local IP address. The IP address of my machine is 192.168.1.109, and then the source port is 49158 and 49196 for each of these two different sessions that are open. This session goes over to this foreign address. It's probably a website, and here's another one that is another website. What I want to do, though, when I want to show you, is if I open up an FTP session to Cisco.com. Now let me open up another command prompt and do another netstat. And what we see is, here's our TCP session again, and we've got a new session here. And we're going from my IP address. Here's a new port. It'll increment the ports as it knows that they're available. 49251. That's going to the foreign address, which is the name of the machine is download-sj, which I can assume is the Cisco FTP server out there, which is download-San Jose, which is where Cisco is located, and FTP. FTP is port 21. I know this just because I do. What Windows does is Windows wants to make things nice and friendly, and so it knows that FTP is port 21. So instead of displaying 21, it'll just say FTP. That way it makes it easier for me as the user to say, oh, okay, this is my FTP session. But what I can also do, again, is let's open up another FTP session, and then another another command prompt, and then do another netstat. And there's my second FTP, and it's waiting. And if you look at this, my first one is now the state now has changed to a closed wait. Basically, I haven't done anything, and so it's thinking, well, I don't want to leave this open, so I'm going to start getting ready to close this port down because I think maybe my user didn't really want to open this up. So it'll go into a closed wait state, and eventually it'll close this port if I don't use it. But what we can see is, you can see the second connection that I opened up to the Cisco FTP server, and it incremented the port 49252 now as the new port. So I just want to kind of give you an idea of how TCP works with your IP address, to give you some extended addressing on top of your IP address, so you can have all your multiple applications running off of your main IP address. So in our example, our PC comes down. What I did was open up FTP, which was my application. FTP was my session protocol that went over TCP port. In my case, the source port was what was it, 49251 or something like that. My IP address was 109. That's 109 over here. Oops, let me see if I can get this on here. 109. There we go. My MAC address, and then finally on the cable all the way up over here to Cisco's website. So that's how OSI works in the real world, from source to destination. So in summary, for what we went over today, we reviewed what is the OSI model. And the OSI model, again, it's a standard reference model. It's a framework so that manufacturers and vendors of network equipment can ensure that their devices that they create will work and be interoperable. They will interoperate with each other. When I can make my network card, and I can know that it will work without having to plug it into every other known manufacturer out there in the world. We reviewed the layers of the OSI model. There are 7 layers, and you will need to memorize the 7 layers: application, presentation, session, transport, network, data link, and physical. I had to think about it for a second. But what you want to do is come up with a mnemonic. All people should try networking like Phyllis. Please do not throw, what was it? Please do not throw sausage pizza away. That's what it was. Please do not throw sausage pizza away. These types of mnemonics will help you remember and memorize the OSI model, so when you are tested on it, you will know it cold. You need to know it cold. And then finally what we did is I tried to show you a real-life application of how the OSI model works in the real world, and how you can see, how you can try to envision how the OSI model works in our day-to-day lives, and on our computers, on our browsers, when we browse the internet, when we send email, exactly how this works. And then I showed you Netstat, which is on a Windows machine, is a way that you can see your source and destination IP address, source and destination TCP or UDP protocols. Well, you won't see UDP, but you'll see your TCP sessions there. I hope this was informative for you, and I hope you will come back again for our next video in the series for our Cisco Certified Entry Network Technician. Again, my name is Joe Wilson for Router Freak. I hope you have a great day. Talk to you later. Bye-bye.